Uh, it always takes a while for my browser to prepare sharing
No problem.
information. So the first one on the list is the CineML features and versions, and I gave a very, very brief introduction to that at the because it doesn't really work by sharing the presentation mode. Can everybody see my slides?
Yes.
Okay. So basically, when we did CineML, that was the result of a long evolution. I think we had the first in earnest discussion of CineML in Taiwan. I don't know how long that was ago, but almost 10 years. And so at some point we reached a common format and called that version 10, and for a while didn't think very much about the need for possibly extending it. So in CineML, the number 10 is the default version number. If you don't give a version number, then you get version 10. And you can set a higher version by setting the base field beaver, for instance, to 11. But CineML itself, 8428, doesn't say anything about what these version numbers mean. Only that higher means something like later, but not more details than that. So it explicitly says new version numbers can only be defined by a new RFC. And the point, of course, is that we want to have some extensibility. We have a lot of extensibility in CineML because we always can define new fields. So that's a great extension point. But if you want to do something that new field, then we need extensibility. And the version number is essentially a unitary declaration, a one-directional declaration from the CineML pack to its receiver that certain features are needed to interpret this pack as indicated by the version number. And maybe there is a little bit of an assumption here that a higher version number might include the features of lower version numbers. But I think that expectation isn't actually be realizable because we are deprecating features all the time. So it's not in reality a requirement that the version n+1 includes all all features of version n. Now, you may have heard me say this sentence here. And of course, version numbers are not stupid in general. Version numbers are really designed for document revision, software releases, for numbering emissions from the same source, and that develop in a somewhat linear fashion. And we have learned that for protocols and other interface specifications, version numbers create problems. And we usually work around these problems by providing other kinds of extensibility besides the version number. So we may not have to exercise the version number, but it means the version number is mostly useless. And that's actually what happened in HTTP, where we had version 1.1 standardized at the end of the last century. And there was no way to increase that version number, but instead all extensibility was done using the extension point of adding new header fields. So we have discussed this in a number of settings, including the research group. And generally, if we want to have extensibility in places where we don't have an existing extension point, then probably the best way to describe this extensibility is by having features. And actually, we have that in ZenML already, so we can add must understand fields. And if we want to add a new feature 1 to ZenML, we could just add a must understand field, b feature 1 underscore, where underscore is the must understand bit. Set this to something, the value is not relevant, but the point is this is a signal to the receiver that the pack can only be used if that particular feature is there. Now, in the long run, this could get a little bit big because each of these, I mean, you see the JSON version without the quotes here on the slide. This is like 10 bytes for saying I want to use a feature, and if I have 3 features or 8 features, this is starting to get in the way of the usefulness of ZenML as a format for very small pieces of data. So at some point, Ari came up with the idea, let's go back to the version number and just interpret this as a bit field. Yeah, that may be a little bit radical, but if you think about it a little bit, it actually works pretty well. So we are at version 10 now, so the less significant bits, the 4 least significant bits are essentially gone. It's probably not very useful to try to use the bits that are 0 there. But within a reasonable number range, we still have approximately 49 bits we could use. And yeah, one of these bits, and this is the reason why we are doing the whole thing here, one of these bits we could use for the use of secondary units. It was the one thing that was left open when we got ISG approval for secondary units. We didn't say, how is ZenML actually going to use them? We know how they will be used by other SDOs, but we didn't say how we are going to use them ourselves. And having a bit in the version number that says, this is not your grandfather's ZenML, but it's actually using secondary units, would be the way to answer this requirement. So we would use one of these bits right now, and we would still have, this is funny. I thought I fixed this in this slide. So we would keep 48 bits going after 1 bit went for the secondary units. Yeah, 53. Why 53? 53 is the magic number of bits that JSON integer actually has. And 53 is not a massively big number. So if we were expecting ZenML to attract as many features as, say, HTTP, that would not be a particularly wise way to go forward. But it looks like we are not going to extend ZenML in that same pace. And well, if we have 48 codes left, we could say we are going to use 10% of those per year. And that will last a while. I mean, it will get slower at the end, but it certainly will last a couple of decades or so. And at some point, then we will probably add another must understand option to get even more bits. So it's not an unsurmountable problem if these 53 are gone, but they will last us for a while. So all this is written up in the ZenML versions document that is now in working group adoption until May 12th. And this defines essentially the feature system, a new registry, so you can get one of those bits. It reserves the feature code 023, and it updates RFC 8428 to use that version number system. And finally, it actually registers feature code for the use of secondary units. So, do we want to go ahead for this with this? It would be nice to have a few more comments on the working group adoption call, but of course we do not only want to adopt this document, but at some point we want to working group last call it. So maybe collecting some things that need to be fixed now would be useful as well. Questions or comments? Thomas.
Hi, Carson. So it's not extra clear to me what the relationships between dash version and dash more units is. In particular, does dash more units need dash version in order to work or not?
It does. What do you mean by work? So more units was approved with an informative reference to this document. So it's not saying this must be the way you indicate secondary units, but on the other hand, the document has a big hole if we don't come up with one way to indicate the use.
Exactly. So imagine someone else comes up with a different way to indicate this. So how does it work in the end, right? So, and in particular, is the informative only reference to version a wise choice in this respect? So imagine a competing solution comes up from another SDO. What are we going to do? What's the interop story?
Well, the designated expert, I mean, you mean a completely different way? Yeah. Then probably somebody should decide.
Right. Hey, so who's authoritative? Yeah, that's my question. Who's the ultimate arbiter of a potential, clash?
The change controller for SAML is the IETF. So I would expect right now the call working group to make these decisions. And yeah, I would be interested in whether this is a completely hypothetical question or if there's something behind the horizon that we are just waiting for.
It is completely hypothetical. It's not.
Okay.
I'm seeing no threats of such thing happening, but this seems to me like a risk we have intrinsic in this decorrelation between the mechanisms to implement the actual thing and the specification of the more units, right? Of this feature, for this extra feature. But apart from that, I'm okay with the document I've said on the list that I support adoption. I think the bitmap-based versioning is a compact way to encode features is great. I have some small doubts about the small codes point space, right? And because of the inherent scalability problem that we have there and the pressure on the registry that comes from there. But as you said, I agree with what you said. I don't think the pace of new features coming is such that this poses a huge risk on the registry, and it is a limited strategy for dealing with giving out code points. So that was my only, real doubt that I have at the moment, and it is about the relationship between the two documents, and in particular that informative reference that we have from version to here. Sorry, from more units to here.
Thomas, then are you trying to suggest that the more units reference should be like mandatory to implement in a way?
That would be my gut feeling, but I wanted to understand whether you don't see this as a problem, and I'm the only one seeing this as a potential risk.
So let me give you my perspective of that. When we did RFC 7252, we thought we should do the right thing and put in raw public key as the mandatory to implement security scheme. And that created a normative reference to a document that wasn't quite done yet, but was very much stable and ready to go and so on. And then we got a 1-year delay because of some squabble in the security area that 6 years later, I no longer understand what that even was. So my perspective is that in standardization, you can make all kinds of mistakes, but you should not incur a normative reference where you don't have. For me, doing a normative reference somewhere to a document that isn't done yet is malpractice. We are not doing that anymore. The patient is dying when we do that. So for me,
And I understand this perspective.
that's way more important than the other considerations. Yes, it's kind of weird to have an informative reference to the only way to do things and so on, but we can finish more units now and have other SDOs use this in their documents, use the RFC reference in their documents. Actually, more units is leaving the RFC editor edit state right now, so I expect it should be published by the end of May. So anything that throws it back on that track would be unfortunate.
Okay.
Thank you. We also had Ari on the line and in the queue.
Thanks, Marco. So yeah, it's just a quick comment. Like, I mean, I can imagine it looks a bit weird that the only way to use it is actually still a work in progress. But as Karsten pointed out, there's already a bunch of other organizations using the units without actually using ZenML. So they are only using the unit part of ZenML and not necessarily the serializations. So in that case, it's not necessarily a problem that they don't have a way to indicate that because they're not serialized with ZenML. But then again, these organizations then may later on choose to use the serialization, and then it's useful to have the feature in place. So in that sense, it's a bit less weird than it may look on the surface. Like why can we have this mandatory to? I mean, the only way to indicate it coming after the defining the whole feature. And then Thomas, on your other point about the coexistence, I think that was actually an interesting one, because I mean in ZenML we used to have the main way to extend was this mandatory to implement fields, the underscore ones that Karsten explained, and then this version thing which we were actually never planning to use because of all the challenges with versioning. But now when we find actually good use for the versioning with this feature negotiation, it is actually not that tricky here either, because those two ways can also coexist. For example, it could be that you have a set of features that you're accumulating over time, and then you group them together by adding, okay, this feature set is now this single version bit in this newly defined version field. So even if there would be different ways to indicate the same thing, they can luckily coexist in the ZenML packs. So overall, I mean, as I also indicated on the mailing list, I think this is a good way actually to use the ZenML version feature, and that's why I think it makes sense to adopt it and publish it.
Okay. I mean, I think I've made my point clear. I understand thank you, Ari, for by the way, for the considerations. But I think I made my point clear about the fact that yes, Karsten's point is right in the sense that we don't want to have normative to something that is in progress, and block another thing on that. But then we have a scar we would have a scar in the more units, in the sense that we would leave an informative way to do something that instead we meant to do in automatic way. So that leaves space in the future for other things to create interop problems, potentially.
Okay, thank you. Any more comments on this? Okay, then let's move on to the next object on CNML-CT.
I'm trying to get Chrome to actually share the window. Extension to CNML, and we thought that would be almost trivial to do. But then we ran into one interesting detail that I think we have found a workable solution yet, but that's slightly weird. So let's talk about the problem again quickly for those who have missed that. So in CNML, we have these data fields. Data fields can be numbers, strings, or they can be pieces of binary data, and this shows the JSON version, which uses base64 URL encoding for the binary data. And the problem, of course, is when there is binary data somewhere, what does it mean? And one common way of indicating what binary data means is by giving a media type or a content type, actually in the correct terminology. And in the context of CoAP, we do this using the content format header. So we are combining the content type information with content coding information. So we could even have some compression here in there. And the second example actually shows the taking apart version of that. So the first example shows the numeric content format as taken from CoAP. And the second one uses an expanded content type in the form of a media type name followed by an @ sign and the content coding. So this is pretty much the technical content of the document. And the question, of course, is how do we handle the fact that this is new? It wasn't defined together with CNML in the outset. So there will be implementations out there that don't understand it. And CT as a field is generally ignorable. So CNML has inherited this JSON principle that if you don't understand something, ignore it. Except that there may be some cases when it really is necessary to understand the media type. And we thought, oh, easy, let's just do another field called CT underscore, which uses the underscore mark that CNML defines as the must understand flag. So we thought we were done, but then we started to think about what happens when both for CT and CT underscore, there are base fields, so default values for the pack. And these default values then apply to all records. And there are some pretty ugly interactions that I think have been shown. I have some backup slides for them, but yeah, the problem is if you have the wrong kind of default, weird things happen. And yeah, so where do we get the guidance what to do in this case? So RFC 8428 defines must understand options, but doesn't really define how must understand options might interact with non-must understand versions of the same field. So foo and foo underscore are just two different fields from a SNML perspective, and you wouldn't, of course, define a foo and a foo underscore that are completely unrelated. So you would expect the semantic definition to give you some information what to do there. So we have four fields here, the base fields and the per record fields. And we need to define how to resolve this. Now the problem is the resolution process is defined separately per field name. And from the point of view of the resolution process, CT and CT underscore are completely unrelated. The resolution does not know that these might possibly be the same thing. So we do the resolution first. We smear the base field values over all the records that do not have a specific value. We can look at what's there and decide what to do about CT and CT underscore. And again, there are tons of examples. And yeah, so the solution for this that we would maybe like to do is have the per record values of both fields override the base values of both field names. But that's not supported by 8428 because the resolution is done separately per field name. So we came up with a general rule. If you have something like a safe to ignore and a must understand version of the same field, you have to define what to do. And I think it's somewhat obvious that the one that already says that it's safe to ignore would yield to the one that says must understand. So there's kind of an obvious decision how to handle that case. Yeah, but what we don't like about it, if you have a BCT underscore in your pack, must understand, a base field version of the must understand, then you no longer can usefully use the safe to ignore version because that just overrides everything in place. And that's a limitation of the solution number 2, but we have kind of given into the fact that we don't know how to avoid this ugliness. So I think it's still possible to use CT and CT underscore in productive ways. One would just have wished to be able to combine must understand and safe to ignore in a slightly more independent way, in particular from the point of view of being able to combine SNML packs from different sources, and there you want to make sure that you don't have undesirable interactions. Yeah, so that's where we are. And the current document does propose this solution number 2. And so we think we are done with this. But of course, when you have some ugliness in a solution, you may want to have some discussion about possibly resolving this in a different way. So if anybody of you has an idea how to do this in a better way, I'm really interested. Nobody. I'm not surprised. This is a hard problem.
Carsten, one question that popped up to my, sorry for jump, I don't know if, queue, please, sorry, jump in the queue. When, during your presentation, can you have simultaneously BCT underscore and BCT? Can you have both?
Yes, and the logic of solution 2 means that the BCT essentially is ignored then.
So the mandatory one is the only one that goes.
Yeah, if you have a mandatory one for every record which BCT underscore is going to result in, then that always wins. I think Ari has a better answer than I have.
Yeah, just a tiny clarification. From the point on in the pack, when you use the underscore version, it's overridden. Of course, if you have stuff before, records before that, then they are as business as usual. So yeah, and maybe a general comment. So we have not yet come across, actual use where this would be a big problem, but we are more anticipating on various ways this could be combined. And I think this is in particular a problem when you're combining packs from multiple sources. In a single pack, I mean, you would just do the right thing and you wouldn't hit any of these complications. You would, because when you're making the pack, if that CT needs to be understood by the receiver or not. It's more like when it's multiple sources, multiple packs that you put together, where these kind of things become more relevant.
I have some people in the queue. Go ahead, Klaus.
Since you're asking for more solutions, my favorite solution is always to not solve the problem. So if we go back to the original problem that was having this content format indications, then if I see some byte string, I know it's a byte string, but I don't know the content format. So if we then add the content format, I know then the semantics of my byte string. But if we assume that there's a byte string and a content format, and I don't understand the content format indication, then I still know that it's a byte string. So when is it important that I must understand the content format?
That's a bit beauty that Sentiment actually has. It doesn't really say what must understand actually means. Does it mean understanding the field in principle, or does it mean understanding the specific value of the field? It's not really very clearly defined. And
So I simply assume that it's the same definition as we basically have for critical co-op options. You cannot understand the co-op message if you don't understand all of the critical co-op options inside this message. So I assume that if there's an underscore field in a record, I cannot understand the whole record if I don't understand that field.
yeah, but that's an important distinction you're making there. You're saying I cannot understand the whole record, and I might still be able to process the rest of the pack. If I have a must understand field that I don't understand as a field, then I have no idea how that influences the rest of the pack. So essentially, if I don't understand the field, I have to stop processing here. If I don't understand the value, I may not be able to use the record, but I may still be able to use other records.
Okay, so maybe the next step is to clarify what an underscore means.
Yeah, I'm not sure that this is the document that should do that.
No, of course, we should have a draft that clarifies in RFC, that clarifies the original SNML RFC.
Yeah.
Thanks. Next in the queue is Christian.
Just to confirm, can we not unset a field? I mean, if BCT underscore gets set to null, wouldn't that make that base thing go away again? Or asked differently, can the composition rules, how does a base field interact with the value that's actually being put in there? Can those be defined per field, or are they general? it's the value copied in unless it's overridden, in which the case it's the overridden one, and the base value can never go away again.
Well, the resolution process is defined independently of the specific field. So I think the answer to your question is we cannot really meddle this, at least not in CenML version 10.
Thanks.
We don't have a way to reset things, and we cannot do application-specific or field-specific resolution rules.
Arguments about criticality bother me. X509 has been arguing about the meaning of the critical bit for the last 25 years. So
yeah, let's not repeat that.
If they define it, make sure it's clearly defined.
Yes. Okay, I think that's a feedback we can go home with. Maybe get some text that explains the meaning of must understand fields in a better way, because we are interacting with the semantics of that and need to make sure that we are interacting with the right semantics.
Okay, any more comments?
I'm afraid the authors of this draft are kind of tasked with doing this. Sorry.
Yeah, I'm kind of concerned with that too. I think that's actually good material for CNML-BIS. That, I mean, I guess bound to happen someday. And of course, I mean, one option would be that we, as Klaus said, we punt the problem from this draft by not giving the underscore version of the CT. That was actually the original proposal way back. But then this came this like, well, it might be cases where it actually is important. Let's add it. And then we opened the whole can of worms on these interesting interactions, which has been very useful, because I'm sure some future fields will have that much more critical. Here, for the CT, I would argue that having the underscore version is not critical. I mean, there are some cases where it's useful. Maybe when we elaborate on what we mean by the underscore version mandatory understand that's critical. But this particular draft would even live without. So that's certainly one option. But I think that maybe whatever is the best way we can move forward with this document is what we should take here.
Okay, there's no one else left in the queue, so if there are no other comments, we can move to the third item, which is very much discussion oriented.
Yeah, I think we have to take it to the list which of the two options we take. But of course, I like the option with the minimal amount of work, and that's only defining CT and not defining CT underscore. So let's finish that discussion on the list. Okay, I have to stop sharing. And I have to share again. So this is an interesting item on the agenda, because it's not really talking about a specific document, but it's talking about something that probably touches a number of documents. Yes, I'm still working on getting Chrome to actually share this window. This is a 20-second process. It's one of the interesting properties of WebEx. The other interesting property of WebEx is that the browser gets slower and slower in the course of a meeting. Should be coming up. So
technique to make us slow down and enjoy the world.
we just need to yes.
It's there now.
Okay, so we always have had an interesting discussion about one component of REST, of the representation and state transfer model, which is that we have media types on one side, which are pre-cooked definitions of what you would find in a response. And then we have some places where people actually define data in a slightly more dynamic way. So they are not writing a 500-page specification of what HTML5 is, but they're actually sending you a definition of what the data means. And this little discussion point here is about that situation. But I want to start with the basics here. And that's something that started in 1977. So I cannot claim to be responsible for that in any way. So since RFC 733, which become RFC 822 later on, and the basis of our email system we all love, if we have something that uses text-based data in the IETF, something that's based on ASCII or UTF-8, and there is not already a document that defines the structure governing the text. So for instance, JSON tells us how to use ASCII or UTF-8. And there is no other data definition language in use. We always use ABNF to provide a machine-readable definition of what the text-based data actually is looking like, is structured like. So there are a few people who are not part of this consensus. So Hannes, for instance, has occasionally said he doesn't really see what ABNF brings to the table. But I think the majority of people who have had to work with standards or had to guide a standard to a consensus process really think that these machine-readable models are good. So we have been having that for 43 years for text. And finally in RFC 5234, this was crystallized actually as an internet standard document. And yeah, now we have RFC 8610, and I hope we can at some point arrive at the same kind of tacit agreement that when we do structured data, JSON or CBOD data, that we actually describe it in CDDL. And CDDL actually was modeled on ABNF to make this as easy to do as possible. So that's something that I kind of take as a given, and let me tell you why. Well, first of all, English language definitions are ambiguous, they are lengthy. Even if they are formalized, like the one in RFC 7071, they are still, they require some interpretation. And once the definition becomes machine readable, you actually can do continuous integration during the work on the standard, during the work on the document. You can check the examples right away with consistency with the formal definition. Readers can check their understanding as well. They can throw examples of what they think they should be able to say against the machine readable definition, and the machine readable definition will say yes or no. And later on, when the standard is actually agreed, the machine readable definitions can be used in implementation efforts. So you might generate code from that, parsers, or where for a JSON data definition, you wouldn't do a parser in that sense, but you still could be able to derive ingestion code from that. And of course, the implementation might even want to use the machine readable definition to do validation of instances. And the net benefit that I think we are getting from this is we have fewer doubtful cases in interop testing and more interoperability. So I remember the first ROC interop in 2000 or 2001, when like 30 people had come to a place and we were interop testing our new protocol, and we couldn't agree on whether in a particular place there had to be a byte with the value 0 inserted or not. And the text really allowed both interpretations. And at some point, we pretty much had to throw a coin. We didn't actually throw a coin because saving a byte was a good idea. But these are the things that don't happen as often with machine readable definitions. Now, there are also some things that are not so great about machine readable definitions. And of course, the first thing is the learning problem. So everybody who's contributing to the document, everybody who is using the document needs to understand at least something about these machine readable formats to make use of them. So we get a threshold effect that might be less strong with an English language definition. And that's maybe a good argument not to have 50 of these formats, but to actually have a small number, so we only have to learn a few of these formats. There is one other thing that is maybe not at all obvious to people who haven't done tons of standards work. As soon as it becomes easier to communicate some complexity, there is an incentive to add complexity. So that's known by people who have been in the industry for 30 years as the ASN1 effect. Things you never could write up in English because nobody would understand it. You can write down in ASN1, and that's why we have specifications like GSM map, which at the time when it initially came out in 1994 was 500 pages of ASN1, and I think it has grown since. There's nothing the format can do against that. That's something that needs to be done by the discipline of the people who are writing specifications. And occasionally we have succeeded. So in RFC 8710, for instance, we have 2 lines of CDDL. And this is actually what I want to get to, a situation where we don't have to have tons and tons of paper filled with stuff that takes weeks to understand, but actually can do things in a very compact way. And the working group, fortunately, has pushed us towards less complexity here, independent of the definition language. So these are counter arguments, but I think both can be mitigated by doing the right thing. So what do we actually get from a data definition? What is the result of the machine doing its machine readable thing? There are 2 parts of that. One is the validation part. So the data definition defines the shape of the data that are expected. So shape is a term that is deliberately a little bit fuzzy, but that includes, for instance, statements about what needs to be there and what is actually optional. So in many cases, before you actually can make use of something, certain items need to be filled in and others are optional. That's something that the data definition language provides. It can provide valid ranges for variables, define types, and so on. And if it's a good data definition language, it actually can identify extension points. So ABNF doesn't even try. CDDL has something there which could be improved in the long run. But yeah, at least in the comments that come with the machine readable format, you can identify the places where the extension points are happening. So that's one part, validation. And the other part is that a data definition also can be used to augment something you get, an instance you get by additional semantics. So of course the instance has zero semantics at the time you get them. Even if you can properly parse it, you still don't know what it means until you actually assign semantics to the different parts of the data. So much of these semantics are in English language today, and that's okay because we have trouble coming up with good languages for semantics. I mean, even the compiler construction people haven't really agreed on ways to do that. They have some ways now, but it's still an area of active research. And these anchor points can have implicit semantics. For instance, if I just name a field type, then I can go ahead and in the English language talk about the type of an object. We also can have explicit augmentation by rooting the augmentation in some semantics framework like RDF. We do this less often than other people, but it's certainly an option. Okay, in summary, we want to get validation and augmentation from a data definition. So up to now, I think I said things that are pretty much agreed by most people working in this space. And now we are entering some wild speculation. If you don't agree with anything I said on the first 6 slides, this would be a good time to speak up. This is not a consensus call. I'm just trying to find out whether people disagree. Okay, so let's start with the speculative part. To do the speculative part, I need some background. This working group has worked on RFC 6690, the core link format, which was based on RFC 5988. 5988 defines a format for web links, but also defines some structure for these web links and some semantics for the things you find in that structure. And since web links in 5988 are based on text, they are using HTTP 1.1 header fields. Of course, the document uses ABNF to define the text form. So we have things like link equals terminal link, terminal colon, and then 0 or more link values. That's actually an extension to ABNF that is being used here, but it's a pretty common extension. And so on and so on. So that's the level of actually expressing the web link as a sequence of characters. But there are also some structural aspects. 5988 actually tries to capture these structural aspects by giving ABNF for how the structure is mapped by the encoding rules into actual text. And that is a recipe for disaster, and this always goes wrong. So you shouldn't use ABNF to both define one level, which is mapping web links to ASCII or to Unicode, and the next higher level as well, where you essentially have to apply the processing rules in inverse to come up what the structural statements from the ABNF actually are. And RFC 6690 actually inherits this mistake. It hasn't really hurt us a lot, but if you look into the example implementation in the appendix of the old links JSON draft, you see how an implementer is actually hit by this. Actually RFC 8288, which replaced 5988, fixes this. So it doesn't provide ABNF for the whole thing, trying to do both levels at the same point in time. But it uses the processing rules and then describes the results of the processing rules in small snippets of ABNF and leaves it to the English language how to put these snippets together into a larger structure. Okay, so that's one background, which I think is important for the next slide. Now, CTDL can describe a plain old CBOR item or a plain old JSON item, which I have abbreviated as POCIs and POGIs here. But we have this media type called Coral that we are working on. And that's a media type. So we could just declare victory and say we are done. Whenever we have a media type that is based on Coral, we use the media type Coral. And yeah, is that enough of a data definition? It's Coral certainly is a true statement and certainly defines structural rules for this media type. But then again, there is a next higher level of structure. So this Coral document is not only Coral, but it's solving a specific application problem. And in order to properly solve that application problem, certain structural components, minimum expected components, maybe ranges, types, maybe even additional interpretation is necessary to make use of this media type. So we have the two-level problem, and we should not do the missed level mistake that we did in link format. Again, we should not try to apply CTDL to the higher level structure of Coral documents. And let's look at an example. So we have Thomas draft called problem, and which is in working group adoption call, and I just found that I have forgotten to say I want that adopted. So as a, oh, this shouldn't say POCO, it should say POCI. As a plain old CBOR item, of course, that's pretty obvious that there's a little bit of weirdness due to this namespace type naming, which when you take it to Coral becomes a UI. But that's a separate issue. There's nothing wrong with using CTDL to describe this plain old CBOR item. Now, the same things you would express in CTDL when talking about the problem details as a plain old CBOR item, you would want to say when describing them as Coral objects. So we want to do the validation. For instance, we want to have at least the type link relation to be there. The rest is optional. We probably don't need help on the augmentation side, but that may be just proved by lack of imagination. So maybe that is coming in again. So the question came up: do we need something like a Coral data definition language to describe the next higher level that Coral actually provides? So that's the thinking I would like to start. How do we do machine readable definition of what we want to be in a Coral document? And somewhat orthogonal to that, but maybe also worth thinking about at the same time, is can we possibly embed definitions of this kind in Corel? So can a Corel document say the thing that this is linking to is an application slash CBOR, but it actually has some additional structural properties, or it's a Corel document and it has some additional structural properties. So in Corel, I could have something like a link or a form, which provides some data definition information about what is being linked to or what is expected to be sent in a form. And essentially, everywhere where a media type goes now, maybe some CDL or CODL could go, or maybe they even can go together. I just gave the example of saying application slash CBOR plus some CDDL. So that's maybe the longer term question, but the more important question for our various Corel-based documents is, do we need a machine-readable way to talk about what's in a Corel document? Do we need to be able to do classes of Corel documents? We can do instances just fine. But do we need class information, type information, and how do we express that? That's my last slide.
No one else is speaking up right away. How does this differ? Just basically saying we want a system for shape constraints on instances of Corel, just say Corel documents for now. Or is this essentially a system for shape constraints?
Well, we
have shackle and checks, right? The shapes constraints language, which are, yeah, you're familiar with those.
Yeah, we could use shackle as our Corel.
We might want to invent something that's a better impedance match and more native feeling for Corel than just using RDF.
Right. SAHCL, shape constraint language. Yeah, maybe that's suggested literature to take home from this point. Everybody have a look at these W3C documents.
And I'd also echo that I have also encountered, maybe it's just, backing myself into a corner in design, but also many times needed or would have found useful a lightweight way to carry the shape information over the communication, over the air on the wire, which is something you just alluded to a little while ago.
Yes.
One thing that's been discussed in the context of Corel is Corel fetch. And I think that for some cases, but we'd have to explore whether that would work for all, the same format could be used to validate and to describe the fetch, to describe to the server what the client wants. Basically to the extent where the client could say that fetch something in this particular format, or get me something in this particular format, and if the server dereferences it, it's just the same as if the client just sent this description as a fetch payload.
Yeah, one aspect of augmentation could be adding flags. I want this, I don't want this. That's a very different way of saying what you just said.
I think it also ties in, that just reminded me with our discussion about selectors, so that you can identify, so semantically identify nodes in a document.
It is unfortunately not about the core problem here, sorry for the pun, but for the next slide, to augment something like to the application CBOR a CDDL. So basically the example at the bottom sounds awesome. I wished I had that a lot of times, but I'm not sure how to, I mean, we cannot add a signed portion of CDDL, because how do you make sure that this is the actual CDDL you want to have? I mean, with CBOR, you cannot go do bad things, but with message structure, labeling for arrays, for examples, and if that would be a stupid decision for the consumer of the information, having a compromised CDL might be, but still I like it. So I think there are ways around that, and I would like to see that at some point.
Yeah, there are some security considerations. I think that's a good point. We should not forget them.
I have so that's why I was speaking up for the meeting more exotic now, because I have to be in another meeting for 9 minutes now, and but I didn't want to miss this. It was very interesting. Thanks.
I would humorously add that we might want to hurry, because they're talking about JSON path again. If we can come up with a better solution to that, I'd be happy.
Yeah, that's maybe one point I didn't make, which is that the whole thing, of course, spans tons of working groups. So we have the whole Yang environment, which is coming up with large solutions for large problems. We have people like Ulysses Carrion, who's doing his own little JSON schema because he doesn't like the big JSON schema. We have the JSON working group, which has had messages going back and forth for a while about whether something like JSON schema should be done. We have, of course, the CBOR working group, which is working on CDDL. So it's an interesting situation from a standards point of view. And of course, there are dozens of other people out there who are doing something in this space as well. So Michael has this great little matrix which shows a dozen IoT formats or IoT ecosystems, and there's one line in this matrix which shows what they are using for data definition, and that's fun. Michael, do you have a link to that? You published it yet?
Oh, I need to do that. I don't have a stable place right now. Sorry. Let me dig one up and put it in the chat.
You can always put it into the research group repository.
Yeah, I'll do that. I'll put it on the, yep.
So JSON path to me is a bit of a very simple subset, but maybe I'm again lacking imagination how this is likely to become complex, like XPath ultimately got. So the interesting thing about the JSON path is, are you doing this for a single instance? Where you know the instance, for instance, you are inside the instance and want to point to a different place. This is what JSON pointer does in a sometimes a little bit clumsy way. Or is JSON path really designed to handle a class of data items? So you can say something like, out of this array of JSON objects, give me all those JSON objects that have the field type set to green. That's what XPath can do for you. And of course, you in the end you will have a Turing equivalent programming language when you do something like that. But yeah, the question is whether there's a useful subset of that functionality that is an 80% solution. So who's doing JSON path work at the moment, Michael?
So it has come up in the Web of Things group as a part of the looking into discovery and directories and things like that. So there is a company that's, I forget the name of the company, that's implemented a thing directory, and they have used the JSON path syntax as the sort of the query language.
Mm-hmm.
So we thought that was interesting, and the follow-on is to investigate potential standardization of JSON path and JSON schema across W3C and IETF. So we'll be getting contacted from the W3C folks about that, but that's a different discussion for a different time. But yeah, but I guess the point being that there's recognition that there's a general issue here about shape constraints and selectors, and I'm not sure that it's really even one problem, but it kind of starts looking like one problem, or a set of problems with some common solutions that want to be common and want to result in some common patterns and tools.
Klaus.
Going back one slide again.
Yes.
So we heard some input so far, but nobody has really responded to the last bullet on this slide. And I think yes. So it actually makes me quite happy that you are proposing to think in this direction. And to me, it seems a very good idea to have some kind of machine-readable format that we can put in our drafts for describing the shape of Corel documents, for both documenting what the Corel document should look like in the different application contexts, and also for simple instance validation. And as Christian pointed out, maybe fetching is not that different from this instant validation. So you could ask a server, hey, please give me all the items, elements in this document that validate against this shape. So it seems to me a very good thing to do. Do we need it? Maybe not. We can always describe things in English, but I think it would be highly recommendable to have something machine readable in our drafts.
Yeah, so JSON path essentially is a very simple matching language. Doing something like Kotlin would be a very powerful matching language. And as usual, the question is how much complexity do we actually need here, and also how much complexity can we expect people to actually implement. So the Yang people have made use of pretty complex XPath stuff that I really only can imagine in a large honking box with loud fans screwed into a rack. And that's maybe not the right thing for the core working group.
Yes, so I would expect that this, especially the fetch part, is implementable by constrained devices. And I've looked a bit into Shackle and Shacks, and I think I slightly favor checks, and I would try to use that as a starting point to see if we can use that in directly or in some modified version to describe Corel documents, and also try to implement it and see if the implementation is reasonable. I think it's possible to have simple implementations for very expressive validation expressions.
That's funny. Dan B told me that he preferred checks at some point, not recently also. So I've been looking into that same trade-off. Interesting that you favor checks.
Yeah, so some of this is getting a little bit too researchy for the working group. Maybe we can partition this space a little bit into things we can do now and things we should be doing after we have collected a little bit more research. But I could imagine that we try to look at how checks would help us in core. So I think that that's a good thing to do.
On the topic of practical questions, how would we interact with media types in this context? We are already running into difficulties expressing Corel with a dictionary as a media type. I figure if we start talking about Corel with a particular profile, this would make the 64K content formats run out rather quickly, or would need some other solution.
The media types are used to say what the bytes mean, and are also used in content negotiation. So so far the idea is that you can use an co-op accept option, for example, to choose between different dictionaries if you want. And then if we say this document conforms to some shape, it has some shape. I'm not sure if that's something you want to use in an accept option. I think it's more like a resource type. So if you get a representation, you say which dictionary you want, and then the response tells you. And by the way, this document has this shape. But my feeling is that maybe this is not so much a system where we declare much what shapes things have. They just have the shape, and if they have the right shape, it works.
You are distinguishing between shape and vocabulary, it seems.
So I was talking about the static compression dictionary that we're using.
Okay, thanks, sorry.
And the shape of some resources, yeah.
Yeah, yeah, okay, great. So shape would also include the application vocabulary that you're using in your, yeah.
Yes, so for example, for the problem details, I guess a shape would say a problem detail always must have error code, and it may optionally have a human readable description text, and it may have 0 or more, I don't know.
Right. An error code is a structure with an enum of severity levels, blah, 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 yeah.
Yeah.
Seems to me that the problem details draft will be the guinea pig here. Sorry about that, Thomas.
I'm fine with that. Sounds nice.
But we also have some more Corel-based applications now, like Marco's group manager draft. We have the proposal for the pub sub draft that uses Corel and so on. And most of them already define in some way the shape of the core documents that are used, but of course in English. So we could try to come up with something not just for problem details, but also for those other drafts and see how that would look like.
Yeah, we currently have an issue on, it's not exactly related, but it's related to how we do templates and stuff. And so if we could come up with a better way of describing things overall, I think it could work into that, solving that issue as well.
Sorry, I didn't get that. Where do you see that issue?
Yeah, the issue is, and people are saying, and rightly so, that it's really difficult to understand. And I think with Jim, is Jim on? Yeah. It's saying it's really difficult to understand how they're supposed to construct the URIs, but it also has to do with how you construct requests. I don't know if it's exactly related, but the discussion kind of reminded me of that issue as well. And so if we're going to rework the constraint languages, we might think about how we go about that as well. I guess it's not related on further discussion, but maybe I just wanted to plug in a placeholder for that, I guess. A better templating, a better way of describing things other than using this quasi-URI template language. That has more to do with the interactions and not with the data description. So not related, probably.
Okay, so what are the next steps on this? Extracting something like requirements or objectives out of the Corel drafts that we have might be a good thing. I mean, not doing this in a very formal way, doing this in terms of slideware would probably be good enough.
If I might, Carsten, and maybe Klaus too, could it be possible to have, since you're talking about having the problem description as a guinea pig, could it be possible to have some example of a draft using this, so that others with other Corel drafts can start working on it as well? I think at least for me, it's so much easier with examples.
Yeah, but before we can do examples, we have to have a design, and before we do a design, we need some requirements. So I was trying to start from the requirements. I love jumping into examples early, so that's a good point. But I think we also need to understand what are the properties of the thing that we are trying to build here.
Yeah, I would start by creating instance examples for those different drafts. And once we see the instances, we can try to see what we would want to describe for the class for these instances. And I suspect it will be things like we expect these elements, and some are optional, some are 0 or more, some are 1 or more, and so on. And data value ranges, for example. And then I think we're pretty much already at checks.
I was going to call them constraints.
Yeah. There's always this tension between the generative way at looking things and the way that essentially assumes that you have a generic generative grammar and are defining constraints on the set produced by the generic grammar.
Are we talking about validators versus constructors?
Well, you can build constructors and validators for both.
Yeah, right.
But how do you express things? Historically speaking, it's essentially the difference between schematron and relaxng. And we know that RelaxNG was pretty successful, and Schematron had its uses, but was less useful in a standards defining environment than RelaxNG. So that's why I'm always a little bit more inclined to take the generative approach. But yes, you also need those predicates, these constraints.
I agree that I've found that these languages that focus only on constraints tend to not be useful in a generative context without adding some other things to them. But so it's almost like a subset.
Okay, I think we have had some good discussion, and I like Klaus' idea of creating instance examples, and I would love to do the next step of extracting requirements, things that a CODL needs to be able to do from those examples. So I think we have some interesting work we can do next.
Okay, thank you, Carsten, and all for the nice discussion. We are just in time to wrap up for the meeting. If there's anything else you want to raise on this last discussion, especially, we can adjourn the meeting and talk again in 2 weeks.
Thank
See you all in 2 weeks.
See you then.
Bye. Bye.
Bye bye.